In this video, we're going to talk about dilution. Dilution is where we take a concentrated solution, take out a small aliquot of that, dilute it to some volume, and thus create a new solution that's lower in concentration. Let's do kind of a conceptual cartoon example of this process to derive the math that allows us to predict final concentrations with known initial concentrations. Let's start with 1,000 milliliters or 1 liter of solution, and I've drawn 20 little blue dots in here so we can pretend there are 20 moles. So let's say that this is 20 moles per 1 liter, so the initial concentration is 20. Let's perform a serial dilution using this as the starting solution. We're going to remove a 100 milliliter aliquot of this 20 molar solution. Notice if we remove 100 milliliters of this solution, there will be 2 moles worth of particles in that 100 milliliter volume. We're then going to take that 100 milliliter aliquot and deliver it into a second beaker. The next step will be to dilute that solution to a total volume of 1,000 milliliters. Notice that when we dilute to a total volume of 1,000 milliliters, there are still only 2 moles worth of particles in the final solution. The question now is, what is the final concentration? What is C2? I think you can see looking at the picture that there are 2 moles in 1,000 milliliters, or 2 moles in 1 liter, therefore the final concentration must be 2 molar. Here's the equation you would use to do this type of calculation. C1 times V1 is equal to C2 times V2. What this means is that the concentration initially times the volume initially is equal to the concentration in the final state times the volume in the final state. Let's plug in the values we have from the kind of picture above and see if we calculate the molarity we expected. Looking above C1, that's the initial concentration of the solution, and that is 20 moles per liter. V1 is the volume of the aliquot, that's 100 milliliters or 0.1 liters. C2 is the variable we're solving for, and V2 is 1,000 milliliters or 1 liter. Solving for C2, we see that C2 is equal to 2 molar, just as we expected or observed here from our visual representation. Let's look at why this mathematical statement is true. Why is C1 times V1 equal to C2 times V2? The concentration is changing on both sides, and the volume is changing on both sides. But there must be something that is equal because we can set those two products equal to each other. Let's do unit analysis to figure out what that quantity is. The concentration in molarity is moles per liter times the volume in liters gives us units of moles. What is equal on each side of this expression is the number of moles. This equation is telling us that the number of moles of particles that we start with has to be equal to the number of moles of particles we end with. That is, moles 1 must be equal to moles 2. You can perform multiple dilutions in a row in what's known as a serial dilution. For each of the dilution steps, you simply use the C1V1 equals C2V2 equation to calculate the final concentration.